Hi everyone. These are the 4 ways of calculating reference angles in case if theta is in quadrant 1 or in quadrant 2 or in quadrant 3 or quadrant 4. As you have seen in the slides, that reference angle we usually refer to it as theta prime, as you can see. If we are in quadrant 1, reference angle is equal to theta. So if this is 30, for example, theta prime is also 30. Okay? And remember, reference angle is always an acute angle. If we are in quadrant 2, if our terminal side lies, this is initial side, this is terminal side. If our terminal side lies in quadrant 2, then to find the reference angle, this is going to be the reference angle, which is the angle that lies between the terminal side and the x-axis. So by default, if this is, for example, 160 degrees, then obviously this piece would be 20. So you can know the rule by yourself that it's 180 minus theta, or if it's in radians, pi minus theta. In quadrant 3, the angle exceeded 180 because 180 is here. Let's say this angle is 200. Okay? And I want to find the reference angle. Where is the reference angle? The reference angle lies between the terminal side of theta and the x-axis. So it's here, and this is it. So obviously, if this line is 180 and all of the angle is 200, then this is 20. How did I know? I did 200 minus 180. Remember, reference angle is always positive. If you get a negative number, then you used a wrong rule. So theta minus 180 or theta minus pi. And in this case, in quadrant 4, the rule is here is theta prime, and to find this piece, I would definitely do 360 minus whatever this angle is, let's say 300, because here is 270. Approximately, I chose 300, so this would be a 60 degrees. Okay, all these rules will be used under one circumstances. Okay, what is this? Under that, the theta is in this range from 0 to 360 or from 0 to 2 pi. If the angles given in the questions are not between 0 and 360 or 0 and 2 pi, then you have to fix that by adding or subtracting multiples of 360 or 2 pi if it's in radians. Otherwise, you will come and use these rules and they will all be wrong. For example, you have example 3, or I would prefer doing this one first. Sketch negative 150. Ask yourself the first question, is negative 150 lying between 0 and 360? Of course no. I know you can draw it. You can go clockwise. This is 0, this is negative 90, this is negative 180. You can sketch it, initial side. Let's say this is negative 135, so let's say here I can sketch it something like this, that this is negative 150. But then I would think about the previous rules and say I'm in quadrant 3. If you forgot about this point, you would just go to the rules of quadrant 3. The rules of quadrant 3 says theta minus 180. So you would think my theta is negative 150 minus 180, and you will totally get a wrong answer. And anyways, reference angle is never negative, it's always positive. So what is the mistake? The mistake is that I wanted an angle that lies between 0 and 360 first. If you want to sketch the reference angle, definitely it's between the terminal side and the x-axis. This is theta prime. But the first step over here is to find a co-terminal angle that lies between 0 and 360. So if it's less than 0, you will need to add 360. If it's more than 360, you will need to subtract 360. So in this case, negative 150 plus 360, which would give me, okay, 0, okay, that would give me 210. 210 degrees, I will deal with it. I can deal with 210 degrees, okay, because it's between 0 and 360. Then I can go to the rule and say 210 minus 180 is 30 degrees, and this is theta prime. So if you miss this step, in this case, when the angle is not between 0 and 360, you will totally get a wrong answer. Okay, another example also you have as 520. Take a second to think, or a minute actually to think, and you can pause the video and then come back. It's 520. It's not between 0 and 360. I need to fix that before finding the reference angle, or before knowing in which quadrant is this. It's easier for me to know the quadrants when the numbers lie between 0 and 360. So here it's more than 360, then I'm going to subtract 360. Sometimes you will need to subtract multiples of 360, more than one 360, right? Until you get a number. I know as long as you can add and subtract, I know you will be able to get a number between 0 and 360. So if you subtract 520 minus 360, you're gonna get 160 degrees, which is very good for me. So 160 degrees lies in which quadrant? It lies in quadrant 2. So in quadrant 2, what was the rule? It was 180 minus theta. And my theta over here is 160. 160 is the same as 520. They both lie in the same place because they're called coterminal angles. They both lie. 520 is just a 360 and then 160. Okay? And 160 is just this piece. So they have the same initial side and the same terminal side, so I can treat them exactly in the same way. This is the 160. The 360 is all the way one round plus the 160. They are in the same place in quadrant 2, and the reference angle is 20 degrees. I hope I clarified this point to you.